Hello, welcome. I'm Rosario Borgesi and I'm a software engineer. Today I want to discuss an important topic about the Ethereum development, which is the ERC20 token. The ERC20 standard, as we will see, is a special type of contract which allow us to create new cryptocurrencies like um, uh, for example, Tether, also called USDT. So, if you are curious to know and to understand how these cryptocurrencies are created, this video is for you. So, I hope you will enjoy it, and of course, feel free to ask me anything in the comments, and I will answer back to you as soon as I can. So, let's get started. This is a Medium article that I have written in order to explore what are the tokens in general and to be specific, what are the ERC20 tokens. So let's start by talking about what are the tokens. We can think of a token as a representation of something that can be real or imaginary in the blockchain. So tokens can be used to represent anything like reputation points in an online platform, lottery tickets, and financial assets like share in a company, a fiat currency, or even real world assets like real estate. The basic difference between the tokens is this. We can have fungible tokens, which means that they are interchangeable with each other. Think about it like $1 is always equal to another dollar, so we can exchange them. But non-fungible tokens or NFTs, they are unique and not interchangeable because each token possess some attributes that differentiate it from another token. So the ERC20 token, the ERC20 standard deals with fungible tokens. So as you can see, there are some properties of this fungible token like interchangeability. As we said before, fungible tokens are interchangeable. Uniformity, all units of a fungible token have the same amount and the same value and properties. Divisibility, fungible tokens are divisible. And example of a fungible token may be cryptocurrencies like Bitcoin, Ethereum, or stable coins like Tether, and so on, Chainlink, and so on. So, as we said before, the ERC20 standards, it has been introduced to um, uh, give a standard to create fungible token. Um, there are various examples of ERC20 tokens in the Ethereum. In Ethereum, like we can see Tether, USD Coin, Wrapped Bitcoin, and etc. So I would just talk about some examples of the ERC20 tokens, some use case. Obviously, I will give you you will find the link in the description of this article. Some example may be stable coins, like we said before, Tether, or we can use the ERC20 token to create security tokens um, security tokens which we can use to build stocks, bonds, etc. Or we can also use it to create utility tokens which are more useful in the application like video games to create um, some currency which you can use in some video games. So we said before there are three example well known of ERC20 token which are Tether or USDT, which is basically a token which is pegged to various fiat currencies. Among them, there is the US dollar, but also which is USDT, but there are also other tokens which are pegged to, for example, euros. Then there is also USDC, and which is also pegged to the US dollar on a one-to-one basis. And then we can have the wrapped Bitcoin, sorry, which essentially brings Bitcoins into the Ethereum blockchain. So the most important, we have said that the ERC20 token, the ERC20 standard, sorry, defines a standard. What does it mean? Before this standard, everyone basically created its own token in its own way, but in computer science, there is always the tendency um, to give a standard in order to give the people the possibility to create their own token in a standardized way. So it is more simple to other people to understand how the token has been created, basically. So it defines the ERC20 standard defines some functions which are called methods and two events that every ERC20 token must implement. The function, as you can see, are name, which returns the name of the token, the symbol, the decimals, which are the decimal parts of a single token, and this will be discussed later on. The total supply, the balance, the account balance of an account. So there are all these function and two events, which are basically an event is when it is used to um, print some log into the blockchain. So there is when an event happens, it is registered on the blockchain, and obviously later on can be retrieved in order to understand what happens, or what has happened. So it is important to understand that the most important implementation. So as we said, this ERC20 standard defines an interface, like in Java, no? Defines an interface, a set of function and two events that you must implement. The most famous, most renowned implementation of this standard is made by OpenZeppelin, and which provides the ERC20, which we can see here. It is, as you can see, as the methods that we have discussed before, which is the basic interface, and provides a lot of implementation. ERC20 is the basic contract which implements all the function we have discussed before. So while the ERC20 standard defines what functions and events you must implement, this is a real the RC20 contract by OpenZeppelin is a real implementation of that definitions that we discussed before. So there are also other implementation, which, as you can see, the most important that we will discuss later on are the ERC20 Barnable in order to destroy the tokens, and the ERC20 Capped, which enforced a cap to the total supply when minting tokens. Please bear in mind that when talking about tokens, it is used the word minting, which means creating new tokens, which is different from mining that we use in Ethereum or Bitcoin when new coin when new coins are created. So minting is used in regard to tokens, sorry, while mm, uh, mm, mining it is used when you created new currencies like Bitcoin and others. So after this brief introduction, I would like to delve more into the code part so we can understand better how we can create this token by writing um, code, Solidity code. So I suggest you to also take a look at this second story on Medium, which essentially describes three types of tokens, obviously basic tokens. So the first one is the token with a fixed supply. What is, as you can see here, obviously I will you can find in the description the link to this article and also the link to the repository. You will find all the code with all the text, everything. So this is an example of a token with a fixed supply. What does it mean? Um, as we can see here, we have our GLD token, which extends the ERC20 contract that we have discussed before, which is supplied by OpenZeppelin. And here, basically, what we are we are calling the ERC20 constructor with the token name, which in this case is gold, and the ticker, which is the ticker symbol, which is GLD. So we are why it is a fixed supply, because here in the constructor, which is only called when we deploy the contract, we are saying with the mint function that we are giving the total supply, which is 70 million tokens to the owner. So another important thing that we were discussing before is the concept of decimal. In fact, you can see here that we are multiplying the total supply 70 millions but times the token size, which is 10 elevated to 18. So what does this mean? This express the decimals, which are the decimal part of the of a token, because since the Ethereum virtual machine only supports integer numbers, this is a workaround because we are creating a very great number by multiplying every the 70 million tokens by 10 to the power of the 18. And so we are getting a very great number that allows us um, to divide it um, by using these decimal parts. So as we can see, we can transfer 0.004 GLD token by simply expressing it this way. So with this multiplication, otherwise it, it could not have been possible. So this is a workaround, but in the graphical user interface, you will not see all these decimal parts of the token, but you will only see the integer part. So this must be expressed in all the function that deal with the number of tokens, for example, in the transfer method. And it is also important, in fact, here we are expressing, for example, that we are transferring to the address of the recipient 2 tokens, and we are multiplying by this 10 elevated to 18. It is also important to point out that there is a method called decimals, which in this case will return the number 18, and um, it is useful in order to get the decimals. The second type of token that I would like to discuss is the uncapped lazy, the token with the uncapped lazy supply. This means that we don't have a cap for the supply, but the supply can be increased. This is obviously a type of token that could bring problems because, of course, it is inflationary, which means that over time each token will lose value. But it's not worthy to see it. And as we can see, mm, the contract is very similar to the one that we discussed before. In fact, still the token is extending the ERC20 contract. And in the constructor, we are still calling the mint function, but we are giving the possibility to create a new token with this other function, which is a mint token, which will send an amount of token to this address, which is who is calling this function, the address that is calling this function, and it will send an amount which is the one that we are passing to this function, obviously also in this size, in this case, multiplied by the token, the decimals, token size which represents a decimal. So this is not a good token, as we discussed before, and should be avoided because it is always good to set a cap for our token supply. Of course, here we are discussing the possibility um, to express in the arguments of this function the address we want to send the token to. And another type of token, it is the capped lazy supply token, which in this case is a little bit different because we have the possibility to increase the supply of token, always with the function mint token as before, but the main difference is that the mm, the supply of token is capped. In fact, in the phase of deployment, when we call the constructor, we are deploying, we are creating 70 million tokens, but we can create new token, but we cannot create more token than 100 million. So this is the reason why we are extending the ERC20 capped contract also by OpenZeppelin, because it allows to specify a cap for the supply of our token that cannot be uh, w- and we cannot mint more tokens than our cap supply. So this is a better example than the one that we have seen before. And another discussion, another topic which is noteworthy to talk about, it is the security and access control. What does it mean? Right now, the function mint token, as we see here, can be called by anyone, but we don't want this in the in a real case scenario, because we want that only the owner of the contract will have the possibility to call this function. But in order to specify the owner of the contract, we should extend also the contract ownable. The contract ownable, which by default express the address which is deploying the contract, which is calling the constructor as the owner. So the owner are ourselves, which are deploying this contract, and this way only from our address we can call the function mine token, preventing that other address can have access to this function, and so to that they can jeopardize our tokens. So this is another important feature. And another thing that it is important to discuss is the possibility to burn tokens. So in this case, we must extend the ERC20 burnable contract, which allows us to call the burn function, which like in the case of stocks buyback, allows the owner of an amount of token to destroy a part of his tokens, and this way the remaining token can acquire a greater value. Also, there is a function called burn from, which can burn an amount of token from another address, but in this case we must specify the allowance. Otherwise, we cannot call this function. Then there is an example more complex, which takes into account all the features that we have seen before. So it is a token which is with a fixed max supply. It is burnable, and also it gives us the possibility to specify the owner. So One thing I didn't said before is that here, because we didn't talk about the ownable constructor allows us to specify the address which will be the owner of this contract. So it is done via this constructor. So in this case, in our constructor, we are calling the ERC20 basic contract where we specify token name, as we said before, and the ticker. Then we call the ERC20 capped constructor where we specify the max cap of our token. And as we said earlier, the ownable constructor. Then, like before, we called the mint function, which allow us to give the first amount of tokens, which are 70,000 to our address, and then we can also sorry, another thing to point out here is that here the max cap of the tokens can be passed as an argument here. So basically the ERC20 cap, the contract, will take as an argument the cap supply that we are providing here. When we deploy the contract, we will see this more in particular later on. And then another argument of this constructor is the reward. What does it mean? This is the reward that we want to give to the node that it is mining our block. So like in Bitcoin, we want to give a reward to the address which will which will add our block to the blockchain. So here, as we can see, there is a function update, which is called, which we had to express because there are two update function in the ERC20 contract and in the ERC20 capped contract. Why is this? Because the ERC20 contract is extending is inheriting from the ERC20. So in fact, we are not extending it here. But we must override the update function. In fact, we are specifying here virtual override. So what here we are also expressing the our custom logging for the reward of the miner, because this function gets called when we transfer tokens or when we burn tokens, and so we can express our custom logic. Our custom logic basically is wants to reward the miner, as we said before, that is validating this block, the current block. So the block which is called and is calling, for example, the update function. So in the case that we are transferring or burning tokens, and so we are calling this function, which is a mint reward function here. And what happens here? We are basically transferring to block.coinbase is the address that is validating the block. We are transferring to this address the block reward. But before we do this, we must perform some checks. Like here, the from address must be different from the zero address, because the zero address is the black hole, is the address without any private keys. So basically when if you are transferring the tokens to the zero address, you are losing your tokens. Um, then the two address must be different from the node the block.coinbase in order to avoid that there is a loop of rewards. And the finally the address the block dot coinbase must be different than the zero address. So this is this is basically what does this contract. And also we have given us the possibility to change the block reward. So in order to if we would like to change the reward in the future, we have this possibility. Before playing with the code, you must perform this operation. So first of all, you must install the MetaMask extension for Google Chrome. Then create an account with MetaMask and save the seed phrase. Then you must add the Sepolia test network to your MetaMask account from chain list at this URL. Then you must add some test ethers to to the address of the MetaMask account you have created by using this faucet. These are test ethers. And then you must register to Infura in order to get the API key. In fact, the API key is what allows us to connect to the blockchain and deploy our contract. And then you can clone this repository where you can find all the examples that we have discussed before, plus the tests. You should have something like this, which is the MetaMask exemption. And then this is the Sepolia test network. And as you can see here with the faucet that we have that I have told you before, I have sent some ethers to my account. These are test ethers, which basically are needed in order to interact with the blockchain. But these are fake, so we don't risk anything. And this is important because we must test our code in the test network because in order to avoid to spend real ethers in the main network of Ethereum. This is the repository I have created. As you can see, there are various branches because every branch has a different type of contract that we have discussed before. But for this demonstration, we will make use of the code in this branch. But of course, the process can be replicated to the other branches. So the example that we are exploring right here um, can be used also in the other in the context of the other repository. So I have created repository on the desktop which I called ERC20 video YouTube. I want to clone the code of this repository, so I just type git clone. Okay, this will clone the repository in this folder here. So this is our folder. I'll get inside this folder. No, of course this is wrong. I must do. Okay. Okay. So we are in the main branch. We want to check out to this branch here. Okay. So it has downloaded all the code. We can open up Visual Studio Code at this repository. Okay. So now we can just we have here we can resume all the steps that we need to set up our repository. So we have cloned the repository. Now we have to create a .m file with these two um, strings, private key and Infuria Sepolia endpoint. The first one is the private key that you can get from your MetaMask account. And the second is the APK that you can get from the Infura website where you have registered before. So I have created my own file. The strings are we have to keep them private. We have have we must not share them with others, of course, because the private key is important that we do not share this information with others. So basically we have the contracts folder where we have the contract that we have discussed before. Um, then we have this folder scripts, which um, is the script used to deploy. Um, and then we have the test repository, which has um, the tests. So to download the dependencies, um, we need to write npm install, and it will download the dependencies in the node modules like every other JavaScript project. Sorry, this is a TypeScript project because we are using TypeScript. So, but of course the libraries are the same, are in a JavaScript project, and here we have the RDACT configuration file where you can see we read the endpoint and the private key we have specified in the .m file, and of course there are the package.json and tsconfig.json that we have in every project TypeScript. So we have installed the dependencies. Now, if we want to coming back to our README, if we want to compile the contract, we just need to write npx at compile. As you can see, he has compiled, which means that it creates an artifact repository with our contract here. There are all the files that he has created. I want to discuss a little bit the test file before we run the tests. Essentially, this is a classical the unit tests that you you have seen many times in a JavaScript project. This is here we deploy uh, essentially the contract, and we get some addresses um, uh, from the blockchain, the RDAT blockchain, because we are deploying the contract to a local blockchain provided by RDAT. I forgot to tell that we are using RDAT as which is a framework that contains the Ethers library. So it is very useful. I suggest you to use it. Um, Firstly, because OpenZeppelin suggests it, and secondly, because it really about you to make a lot of work, because without it, it is really hard to compile this ERC20 contract. Then after this, before each block where we deploy our contract and get the account of our mm, RDAT blockchain. What we are doing? We are testing the deployment. So here, basically, we are testing that the owner is the one expected. So this is the test for the owner. Then we test that um, it assigns the total supply of the tokens to the owner. In fact, when we, as you remember, when we, this is the owner balance and is expected, okay, to the token total supply. Okay, because as we said before in the contract, in the constructor we are deploying, we are giving this 70 million tokens to the owner. So here basically we are testing that this owner effectively has this token. So then we are testing that it has effectively set the cap supply in our contract, and then the block reward is set as expected. So um, these are the tests related to deployment. Then we are testing some transactions, like the transfer of tokens between account. For example, then we are testing that it should fail if the sender doesn't have enough tokens, and we are testing that it updates the balances after the token transfers. So very simple tests, basic tests. Then we are testing the miner rewards. We are making sure that effectively the the miner gets the reward. This is an address that um, is the address of the Coinbase address that adds the blocks to the blockchain in the local RDAT in local RDAT blockchain. I provided also the link which explains this. And then we have tested the burning of tokens, because here we are just testing that the burn function works effectively. So since we have the possibility to burn the tokens, we are testing that our burning function correctly. So this is basically what our tests are doing. Of course, if you like, you can add more tests. Then I would like to test this contract. So we run this file that we have discussed here. Now I forgot to copy the key. Okay, this basically runs that file that we have discussed, and the tests are all right. Then if we want, we can deploy the contract to Sepolia by running mm, this script, which essentially deploys the contract. And we can do it by executing this command here. Is deploying the contract. Okay, the contract has been deployed to this address. If we want, we can check it on Sepolia Etherscan. So we check this address, and maybe it's still. We need to wait a while. Okay, now we can see the transaction. Mm. Okay, now we see the token tracker, which is gold. And if we like, we can import to MetaMask these tokens. This way, we select tokens. Oh, no. Tokens, yes, import tokens. We select this. As you can see, he's already find the token, which in fact he has found that the token symbol is GLD and the token is the 18 decimal. We select next, and if you want, he is importing these tokens uh, in our account. Uh, Obviously, importing the tokens, sorry, means that we can see it right here. Now we can also go to Remix if we like, and we can play around a little bit with this code. We can just take this code. What we go here, we copy our contract and paste it here. Okay. Then basically when the error that we had before was due to the fact that is Open Zeppelin in Open Zeppelin we cannot import uh, the contract in this way. We have to provide the whole mm, GitHub path. So now the error that we had here is gone. Now we can compile the contract and we can deploy it to MetaMask. So we have selected, I have two accounts. The first account, we now need to get this address that where we have deployed the account. We paste it here. No, sorry, here. Basically, we are Remix allows us mm, to work with the account that we have deployed on Sepolia, on the Sepolia test network. Here we are getting we can work with the account that we have deployed. As we can see, if we run the block reward is we have set a block reward of 50 tokens. Of course, this number is comprehensive of the decimal. In fact, we can see that it has 20 numbers. So there are 50 tokens because the 18 zeros are related to the decimals. If we um, here if we press this, if we call, here we're calling the function, not payable while these are payable. The cap of the token is 100 million, decimal are 18, the name of the token is gold, the owen is the address FE28, which is exactly this one, FE28, and the symbol is GLD. The total supply now is 70 million because we can increase the supply. In fact, we can also try the balance of, for example, this account, the first one. This balance is 70 million tokens, but we can, for example, transfer some tokens to the second account here, account 2, copy, and this account has to have a balance of 0. Okay, we transfer here, no, 10 tokens. So we must set 10 plus the 18 zeros this way. Okay, we are sending 10 tokens. So we press comma, transfer, send transaction. Of course, this is payable because it's orange. 10 gold tokens. I'm transferring from no, account 2 to account 2. No. We are making a mistake here. This is not good. Close. Okay, I selected the wrong account. Transfer. Okay. 10 tokens from the first account to the second one. Confirm. Okay. If now I call balance of the second account. Okay, is waiting. Okay, we should see, of course, 10,000 token, 10 token. Okay, it's the same. Now, for example, let's say that the second account so has this 10, 10 token. Let's say that second account wants to burn this token. We can choose the second account, burn. No, I didn't put the value here, burn. Okay, equals the transaction here. We are burning this token, confirm. Okay, everything went fine. If I calculate the balance of, okay, I see 0 token. So the token were burned. So if you want, you can play with the other function. And I believe this is pretty much everything. And of course, if you like, you can deploy your contract to the main network just by changing here the provider. So for the mainnet, it will change of course, the URL of the provider, which is Infura. So we have reached the end of the video. I hope you have enjoyed it. We have covered the whole topic of the ERC20 token. We have discovered how they are created, how they are, how to test them and to deploy them to the to the Sepolia test network. I hope the video has been useful. I thank you for watching and I hope to see you again in my next video.